So we've got, after today, we've got 4 more classes. Good, good. We're finishing up good here. We're going to dwell on this last chapter a little bit more. I kind of rushed through that last year and nobody did any good on it. Imagine that. Okay, this is chapter 14 and doing the practice test here, or the test in the book. The total surface area, wait a minute, did I get the test? I think I did. Maybe I didn't. I'm going to have to send you the test, guys, I think. Let's see. Emma. Has anybody got anything to turn in? Okay. Okay, good.
I think I have a filled out page of a test on my person right now, but it's not sorted and I have no idea what test it goes to.
This page?
Oh no, where is it? It's not this one. It's this one. Oh, it's chapter 8. It says on the 10th.
Okay.
It's only in one page. The others are scattered throughout my house. I need to
Keep them together.
Yeah.
Bring it sometime. Okay. All right. Goes there. That one goes there. There we go. Now we're rolling. Tell whether each statement is true or false. I'll put it up here like this so you can see it good, I hope. The surface area of a rectangular solid is the length times its width times its altitude. True or false? Rectangular solid, length times width times altitude. And that's the surface area. Well, that's actually length times width times altitude is actually the volume, isn't it? So that's a false statement. It's a false statement, okay? The volume of the surface area of a sphere can both be calculated if you know only the radius of the sphere. Is that right? I mean, what else is there to know about a sphere? So that must be true. Because one of them's are squared for the surface area and the other ones are cubed. Okay. The volume of a prism equals the product of blank and the blank. Volume of a sphere. Yeah. Remember that one? Prism. Volume of a prism. You know, prism looks like this is a hexagonal prism. If I can do this. There we go. Very good. Okay, so it's saying the surface area, the volume. Okay, so how do we do the volume? What's the volume of a prism? If you found out the area of the base, that's the area of the base, and then you make a bunch of them and stack them on top of one another, it'd fill it up, wouldn't it? So it's the area of the base times the altitude. Okay, and that is okay. Oh, you guys don't have this, do you? Area of the base times the slant height, which is altitude. No. Slant height is on a pyramid. That's the slant of the triangle. Yeah. So area of the base times the altitude. Okay. Okay. Number 4. Okay. And we'll do it like this. Let me get it over here, so maybe we can see it a little bit better. Yeah. Okay. Number 4. The total surface area of a prism is equal to the product of the blank and the blank of a base plus 2 times the blank of a base plus 2 times the blank surface area product. This is not right. Isn't this surface area Alright, I'm going to look for that formula here. Surface area of a prism. Base area. Oh, no, that's part of the test. Oh, I don't have that. Should have it. What's in this book? Anyhow, the surface, the formula is area of the prism, I think, is equal to 2 times the base, 2b, plus AP. 2b plus AP. That's 2 times the base plus the altitude, AP, plus the altitude times the perimeter. That's the real formula. But I don't know how we make that out of these words here. Because it's a product of the, altitude and the perimeter of a base plus 2 times the area of the base. Altitude, perimeter, yeah, right here is B. Altitude times perimeter plus 2 times the area of the base. Okay, that works. Your test is not going to, that's not going to be the exact question on your test, so just look at the formulas and see what applies. Okay, the volume of a cone is equal to, and who knows this one? Who knows what goes in that blank right there without even reading the rest of it? The volume of a cone is equal to something times the area of the base times the altitude. But since the base is circular, the formula is written by, okay. All right, a cone. Anybody remember the magic thing about cones and pyramids?
I think it's 1/3.
Yeah, 1/3 is the magic number. So you just make a cone out of this, or a cylinder out of this, and take 1/3 of it. Right? So if we got a cylinder here, draw that a little better. Cylinder, round like this, right? Okay, that's supposed to be round. Make that. If we simply want the volume of this cylinder, we just take this base and stack it on top of one another. So it's the area of the base times the height, and the area of the base is the area of a circle, which is pi r squared, times the height, or altitude. I don't know if they use height or altitude. It's both the same thing. I'll say altitude. All right? And then, if it's a cone, that cone would fit in there like this. Okay? And it's always going to be 1/3 of the entire volume. The volume of the point of the cone sitting in the middle there is 1/3 times the volume of the whole cylinder. And the same thing works for prisms and pyramids. So you can draw a prism like this. That's a prism. All right, draw it like this. There's a prism. All right. If you put a pyramid in here, it would look something like this. I don't know, I can't hardly draw that. But it would be the volume of this pyramid is 1/3 volume of the whole rectangular solid there. Okay. Everybody understand that? It's like taking these and stacking them on top of one another till it fills it up. That's the same as taking this and multiplying it by that length. All right. Okay. Number 6. Calculate the area of each shaded region below. Give your answers in terms of pi. Okay, I don't think we need that anymore. So we've got a circle here. Right there's the center. And now we draw another little circle right there, okay? So that's O, and this is A, and this is B. All right, got a dash line through here in the book, B, okay? And that distance there is 8. So that is the diameter of the circle, right? It goes through the center. Diameter equals 8. But they want the shaded region. This is all shaded in here. This is all shaded. Okay, so we got to get this shaded region. So if we take the diameter, the area of the circle, and subtract the area of this circle, we'd have it, wouldn't we? That'd give you the area of the shaded region. And that's pretty easy to do. The area of the big circle, that means that the radius is 4 if the diameter is 8, is going to be pi times 4 squared, which is 16. That's the big one. And the area of the little circle, it's going to be 4, and then half of that is 2. So it's 2 squared is 4 pi. So the answer is 16 minus 4 is 12 pi. Okay? So you got to kind of look at these and just use your head. You know, see how to break these things up into figures that you know. Okay. Again, there's another one like this, except it's a square and a circle. Okay, looking at this, the radius of that circle is 11. Who can tell me what the length of the side of this square would be? You got to think about it a bit. What's the length? If this radius is 11, what's the length of this side here? Let me ask it this way. This is a circle. If this is 11, what's the length of this radius? 11, yeah. So remember, all radius of a circle are congruent. So now, what's the distance all the way across here? The diameter.
22.
22, that's right. And that's what each side is 22. Okay, so now you can figure out the area of the square, which is going to be 22 squared, minus the area of the circle, which is going to be pi 11 squared. Subtract them, and there you go. Okay? All right. Oh, here, we love these things. We love these things. Oh, but they're making it a little easier. Whenever you see a 60, well, if you got something like this, and this says this is 60 degrees up here, well, you immediately know what these angles are. This is going to be 60 and this is going to be 60. Okay, because this is a radius of 6 and this is radius over here is 6, so these two sides are congruent, so these two angles have to be congruent. So these two congruent angles have to add up to 120, because 180 in a triangle, so it's got to be 60 and 60. So we want to know the area of that little part right there. They call it a circular segment, I think is what they call it. Okay, so this is a triangle, equilateral triangle, and it's base times height, 1/2 base times height. Area of the triangle equals 1/2 base times height. Well, we don't know what the height is, but we got to draw, make a right angle. Okay, that's going to be the height, and that's going to bisect 60 degrees. That's going to bisect this down here, and that's going to be equal. I'm going to say this is going to be x and x. Okay, so what? I need to draw this again a little bigger. Let's do it like this. Okay, there we go. We got this. Whoops, that's supposed to come out of the middle to there. Okay, so that means this is, if this is 60, this has got to be 30 and 30. Okay, 30 degrees. The ratio of the sides is 1, 2, square root of 3. And 2 is the hypotenuse. Okay, and that hypotenuse is 6, because that's the radius. Okay, so if the hypotenuse is 6, then, and it's twice the smallest side here, then this must be 3 from here to here. Okay, now we got a base. We got a triangle. Okay, and this one has to be 3 square root of 3. 3 square root of 3. So that's 1, 2, square root of 3. Okay, now we got a base and a height. So the area of this little triangle here is 1/2 onto 3 onto 3 square root of 3. I'm going to leave it like that and say, okay, the area of this whole piece, this whole triangle here, the bigger triangle, is just twice. They're both the same, so it's going to be 3 square root of 3, 3 square root of 3. Okay, so that's going to be 9 square root of 3. Whew. Okay, we got the hard part. Now we have to work on this piece of pie right here. Okay, and that's 60 degrees, so we got to do the ratio thing here. Say 60 is to 360 all the way around as where am I going with this? Oh, no. Yeah. Okay. 6360. Okay. Is pi, the area of the circle is pi r squared, which is going to be 36 pi. That's the area of the whole circle. Okay, pi r squared. There's r. It's 6. So pi r, and then this is what we're looking for, the area of the triangle. Whew. Yeah. Okay, yes. So area of the triangle then is equal to 60 times 36 pi divided by 360. Okay, I'm going to move that up a little bit, and I'm going to say that's going to go. That'll go away if we make this a 6 right here, and 6 will go into this 6 times. So it's going to be area of the triangle is 6 equals 6 pi. Whew. Okay, now the area that we're looking for here is simply area of the triangle minus the area of this, or area, that's a sector actually, area of the sector minus the area of this triangle. It gives that little sliver right there. So area of the sector minus the area of the triangle, which I had right here, which is 9 square root of 3. Boom, we got it. I wish I knew some way to make that easier for you guys. You certainly have to know the 1, 2 square root of 3 thing here. And you realize, of course, that this is, well, I'll show you over here. This shaded region is actually this sector, this pie-shaped thing here, slice of pie, minus that triangle. Okay, that's the best I can do for you. All right. Okay. I don't know if anything like this is going to be on the test. I just don't know. Calculate the surface area and the volume for each rectangular solid below. Okay, we can do this, can't we? Surface area of a shoebox, or rectangular solid. Okay, hard to believe they're giving you the same problem twice, but okay. So this is 10 by 4 by 12, so it's the area of the bottom is going to be, it's going to be this times this, and this is 10, same as this. So area of the bottom is 120. Bottom and top together will be 240. Okay, we'll remember that. 240. Okay? Now all we need is the area of these two sides and these two sides. So these two are going to be 10 by 4, which is 40, times 2 is 80. Okay, 10 times 4. And down here, it's what is this, 12 by 4, 12 by 4, which is 48, times 2 is 96. There you go. There's the surface area. You just add those up. And this one is the same way. I don't have to work that problem. Just realize on these rectangular solids, all these are right angles. They're rectangles. So everything's a right angle here. So that makes this the same as this, and it makes this the same as this, and this, and this. So this is the same as the one I just did. Well, that's about it, I guess. Okay? All right. I got to see what time this is over with. This is third period, 10:40. Oh. And it is, okay, good. We got about 20 minutes. Okay. All right, we have what is this? What is that? Who can tell me the name of this thing?
Prism?
Yeah, it's a prism. Yeah. Okay. And they want to know, what do they want to know? Oh, they want to know the name of it. It's got one more little, it's got a couple of descriptors on it. All right. What kind of prism? What kind of prism? Well, it depends on how many sides there are. In this case, there's 5. There's a pentagon at the top and the bottom. So it's pentagonal. Pentagonal. And oh, by the way, it's leaning over. And what do we call it when it leans over? Oblique. So it's oblique pentagonal prism. Okay? And here we're asked to figure out the perimeter of the base is 24 and the area of the base is 30. So, oh, and the height is 7. Okay. Okay. So what do they want to know? Oh, calculate the total surface area of each. Okay. So surface area of a prism, magic formula, whether it's oblique or regular, area of a prism is equal to 2 times the base plus AP, 2B plus AP, A being the altitude and P being the perimeter. Okay? Altitude, that's kind of weird, and perimeter. Okay? And B is the base. Okay. So there you go. The total surface area is 2 times the base, and they're giving you the area of the base, so you don't even have to figure it out, because that's kind of a challenge to figure out something like a hexagon. We've done it before, but we don't have to now. So the area of the base is 30, so 2 times the base is 60, and then the plus the perimeter of the base is 24. Perimeter of the base is 24. Let's do this right. All right. Surface area equals 2B plus AP. All right. The base, it says here, is 30, so this is going to be 60 right here. And the area is area of the base is 24, and the perimeter, no, that's the perimeter of the base is 24. The area of the base is 30. The perimeter of the base is 24. So there we go. 60 plus 30 times 24. That's surface area. And oh, by the way, if it's leaning over like this, if it's oblique, like this one, still the same thing. It's the 2 times the base, which they're giving you up here, plus the perimeter, which you can figure out the perimeter on this one because it's regular and 1 is 7, so it's 7 times 1, 2, 3, 4, 5, so it's 35 times 2, 35 times 2 plus 35 times 11, the altitude, 35 times 11 for the altitude, plus 2 times the base. And the base is 50. Okay? Just plug it into the formulas. All right. Oh, these are good. Sphere is easy. Sphere is easy. Because the volume is going to be associated with the radius cubed, isn't it? So it's 4 pi r cubed, I think. And the area, this is the volume, and the area is 4/3 pi r squared. The reason I know those is because I've been working with them for 50 years. 60. Oof. It's a long time to work, isn't it? I'm looking it up just to make sure I got it right. Yeah. That's right. That's right. Okay. So that's the sphere. Here's it says the base is a square. You can't see that, can you? Let's erase this. The base is a square. Okay? So it's 10, 10, 10, 10. And the slant height is 11. I don't know if you can see that. It's kind of hard to see. Take my word for it. That's an 11 right there. Okay. So what do they want to know? They want to know the surface area. The surface area. Okay. We have a triangle here. And the base of that triangle is 10. And the height of this triangle is 11. So that's 110 divided by 2, which is 55 for one of these little triangles. No, I'm sorry, that's yeah, 1/2 base times height. Yeah, that's right. That's right. So this whole triangle here is 110. But there's 4 of them. Front, that. So that's 440. And then the base is 10 by 10, which is 100, so it's 540. Some of these you can almost do in your head. Okay. All right. Now we want the volume of these guys. Okay, this is says that it's giving you the base is 770. That's the area of the base. So it's real easy. It's just base times altitude. So it's 707 times 23. Let me put this up here again. Maybe you can see a little better. Okay. That's this one, area of the base, 23. All right, and here is an oblique cylinder. Okay. it's the same thing again. Yep, it's the area of the base times the altitude. And there's the radius, so the area of the base is pi times 9 squared. And then times 27 gives you the area of the whole thing. Okay? All right, we're almost there. Let's see, this is over at this third period, 40. Okay, good. Here's a pyramid. The base is a regular pentagon, 5 sides, right? And that area is 35. And its altitude is 9. Okay? Can somebody tell me how you figure out, what do they want to know? The volume of this. Some of you smart guys, help me out here. They're giving you the area of the base. What's the formula? Oh, y'all took my word for it when I said you didn't have to memorize these formulas, did you? And I don't blame you. I'm not going to ask you to memorize something you're not going to remember. Okay, so it's area times the altitude times 1/3. Okay, a prism would be the area times the altitude, and this is going to be 1/3 of a prism. No, wait, yeah, that's right, volume, yeah. Okay, here's the area of a sector is 40 pi. Find n. Oh, that's interesting. Okay. The area of a sector is 40. Okay. We're given the area. We're given the radius. Okay. We can do the ratio thing here again. We can say, let me write this down. Let me copy this. This becomes a little more interesting. Like this. Okay. We're given that the area equals 40 pi. Okay? So the area of this thing to the area of a circle, okay, let's see, area of the sector to area of the circle, the ratio is the same as what? N. That's the angle. The angle is to 360 in degrees. Yeah, that works, doesn't it? Because circle is all the way around here, and this is just one part of it. Okay, so the area of the sector is 40 pi. 40 pi divided by, and they give you the that's n. So that's going to be 12 squared, 144 pi. 12 squared is 144. R squared, pi r squared, equals n over 360. There you go. You can cross multiply, and you got it. Okay. Oh boy. Look at this. I hate this. I think I'm going to hate this one. They want you to find, they're saying that all these are congruent, which means this is a regular, whatever it is, 1, 2, 3, 4, 5, 6, 7, 8, octagon. Okay. And they want us to find C. Well, shoot, I like this one suddenly. Okay. this is 1/8 of all the angles, right? Of all the pies. So it's going to be 360 degrees around, so it's just going to be 1/8 times 360 degrees. That's easy. Yeah. That makes total sense, doesn't it? Try to make sense out of these things. They're easier to deal with. All right. The edges of a large cube are 4 times as long as the edges of a smaller cube. Oh, remember this. Okay. The edges are 4 times as long as the smaller cube. Okay. Similar. They're similar. What is the ratio of the volume of the small cube, a large cube to small cube? Okay, does anybody remember how to do this? I don't know if you can read it. Get it up there a little bit better. Number 22. The edges of a large cube are 4 times as long as the edges of a smaller cube. All right. So that'd be in linear measurement, right? Inches, feet, something like that. All right. What's the ratio of the volume of the large cube to the volume of the small cube? But that would be like 3-dimensional there, wouldn't it? Cubes. So the ratio then is 4 cubed to 1. Remember, since this is a volume, okay, it's being cubic inches or something like that. And the ratio is 4 to 1, so that's the ratio of the larger to the smaller, which of course is 4 cubed. Okay? And if they ask for area, it would be 4 squared to 1 squared. Because area is 2-dimensional. Okay. All right. Oh, we got some proofs here. Number 24 proves that the application of a regular polygon bisects the sides of a polygon. Okay. We got a little time here. And I forgot to make copies of the test. I'm just going to have to send it to you guys. Okay? I'm sorry. I can't let you go yet. So what we're going to do is this last thing in the book, last chapter in the book, and we're going to take all 4 lessons on this thing. Because like I said, it's my other classes seem to have trouble with it, so I've probably been going too fast through this. So just to give you a little preview for a few minutes here, merging geometry and algebra with algebra. Well, I thought we'd been doing that all along, using algebra the whole time. Well, they're talking about a little different now. Okay. The good thing about this is that it will work every time. They're talking about doing the proofs. They're talking about doing the proofs. We're going to use algebra to do the proofs. How weird is that? It works every time using the same steps. René Descartes. Who's taking French? Anybody taking French? Well, then if you're not taking French, it's René Descartes. Okay? Descartes. The French have a real weird way of pronouncing R's. It's a sound. Descartes. Anyhow, old René here wanted geometry proofs to be more like doing algebra. So he created a way to do that. He called the coordinate plane, also called the Cartesian plane. Get it? That's in his honor. Okay? So what that means is, if I have a figure, I'm getting kind of ahead, but this is where we're going with this. If I have a figure, okay, say a triangle, and I want to prove that the area of this triangle is 1/2 base times height. And maybe that's not a good thing. All right, tell you what. I've got two triangles, and well, I tell you what. Before we get into that, let's talk about the coordinate plane. Let's just talk about this. Maybe that's the reason they put these things in order. If we have a coordinate plane like this, I hope everybody's fairly familiar with this in geometry. Have you seen this before? They divide these things up into quadrants. It means quarter of something. 1, 2, 3, and 4. Okay, have you had that in algebra? Good. And it's always from the upper right, 1, 2, 3, 4, going counterclockwise. And this point here, this point right here, is the point where x equals 4 and y equals 3. And you sometimes see that written as 4, 3. The x always being the first one. Okay. Is that looking familiar to everybody? Okay. Good. This should help. That's probably all I got today. I'm going to let you guys go. Try to be quiet and don't hang around outside your next teacher's door peeking in. And I will be sending you the test.